Hello everyone. So in this video, we'll be solving the past year of Introductory Statistics for Economics. This is for 90 marks. So basically this is of NEP. So this is for 2023 only past year. Now answer may be written in English or Hindi. Same medium you are supposed to use. So you need to answer all questions within each section are to be answered in a contiguous manner on the answer sheet. So you need to answer the questions in the continuous manner. First, then second, then third. And you're supposed to start each question on a new page. Okay, you must be knowing all these things. Use of a simple non-programmable calculator is allowed. I don't know if they will allow the scientific calculator this time or not. But in most of the cases, they allow simple non-programmable calculator only. And statistical tables are also attached. Okay, so part A. So this paper consists two parts, part A and part B. So in this video, I'll be solving part A complete. And so basically question 1, 2, 3, 4, I'll be solving here. I'll just check how many questions in total are there. So in part B, the questions are of 10. Okay, so part A, okay, I'll tell you. In part A, there are 4 questions. Question 1 is compulsory and you are supposed to attempt any 2 from question 2, 3, 4. Okay. So, whereas in part B, you need to attempt only 2 questions from 5, 6 and 7. Okay, so this is 10, 10 plus 5, 25. Every question is of 25 marks. So 50 marks because you are supposed to attempt 2 questions, 50 marks for part B. Now coming to part A, it is 10 plus 5. So part A is 15 marker. This is 15 marker. And since you are supposed to attempt 2 plus 1 is compulsory 3. So the total marks are 45. Okay, I'll just see. Okay, so first question is of 10 marks. First is of 10 marks, then 2 questions of 15 marks. So this would be 30. So 30 plus 10, 40, and then 50 of part B. So this is of 40. Okay, so we'll start solving the questions. Question 1, A part. The first 4 deviations from the mean in a sample of 5 reaction times are. So first 4 deviation from the mean. So we have x1 minus x bar equals to 0.3, x2 minus x bar equals to 0.9, and x3 minus x bar is 1, x4 minus x bar is 1.3. So we have this thing. Answer the question that follows. What is the deviation from the sample mean for the 5th observation? So we are supposed to find x5 minus x bar given these information. So we know, okay, we know summation xi minus x bar. So deviation, sum of the deviation of the mean, sum of the deviation of the observations from the mean is 0. So this is 0. So we have, this implies 0.3, 0.9, 1, 1.3. So we have 0.3 plus 0.9 plus 1 plus 1.3. This becomes 1.2, 2.2, 3.5. Okay, so plus x5 minus x bar equals to 0. So this sum is 3.5. So we have 3.5 plus x5 minus x bar equals to 0. So x5 minus x bar would be minus 3.5. Okay, I hope this was clear. Now coming to the standard deviation, I'll just get my calculator as well. Okay, now coming to the B part, that we are supposed to find the okay. So you are supposed to use a simple calculator only. In most of the time they will allow you the simple calculator only. but as happened in the last MME exam, they allowed for a scientific as well. Okay. Now looking at B part. First question, B part. So calculate the sample standard deviation. So sample standard deviation would be summation xi minus x bar square upon n minus 1 under root. So this is nothing but 0.3 square plus 0.9 square plus 1 square plus 1.3 square plus minus 3.5 whole square upon the number of observations were 5. So 5 minus 1, 4. So under root of this. So if you'll solve this, you'll get under root 3.96, which is 1.99. So the standard deviation is coming out to be 1.99. If each observation is multiplied by 2, what is the new variance? So we found standard deviation of x equals to 1.99. So variance of x was 3.96. And now variance of 2x would be 2 square times variance x, which is 4 times variance x. So which is 4 times 1.99. 4 times, this is variance is 3.96. So 4 times 3.96, which is coming out to be 15.84. So this is the variance. Okay. Now moving on to the next part. What are the degrees of freedom for sample standard deviation? So we know from the formula itself that the degree of freedom for sample standard deviation is n minus 1. Okay. So although we know that this standard deviation, this depends on all the n observations, x1 minus x bar till x5 minus x bar. But since we know summation xi minus x bar equals to 0, we can, so if we know any n minus 1 of these, we would be able to find the next one. Like in this question itself, we knew x1 minus x bar till x4 minus x bar. So we were able to find the last one. So the degrees of freedom is n minus 1. Okay. Now moving to the B part. Consider the following data and answer the question that follows. So the class interval is given to us. Relative frequency is given to us. So we are supposed to find. So identify the class interval in which the sample median would lie. So median distributes the given data into two equal parts. So where 50% of the observation would lie. So relative frequency is given. We can find cumulative frequency. This would be 0.177. Then plus this. So 0.177 plus 0.166. 0.343. Then plus 0.175. So 0.518 plus 0.136. 0.654 plus 0.194. So this is giving us 0.848. Then 0.926, then 0.97, then finally 1. So if it coming out to be 1, then your answer is correct. So if it is not coming out to be 1, you need to check it again. Okay, so 50% of the observation, cumulative frequency, this means till 51.8% of the observation would lie here. So 50% of the observation, so in this interval it is close to 34%. So the median should lie between 10 and 15. Okay, Now we're done with the first part. What proportion of observations? Okay. So the class interval is given to us. We can calculate the density for each class interval. So we know relative frequency is equals to class width. You should know this formula, into density. So density becomes class width upon, okay, so density into class density. So relative frequency upon class width. Okay, class width. This is 5. 10 minus 5 is 5. 15 minus 5, 15 minus 10, 5. 20 minus 15, 5. 30 minus 20, 10. 40 minus 30, 10. 60 minus 40, 20. 90 minus 60, 30. So this is the class width. And you have the relative frequency as well. So we'll get the density. So density would be relative frequency 0.177 divided by 5. So this is coming out to be 0.0354. Then 0.166 divided by 0.5 by 5, 0.0332. Then 0.17 divided by 5, this is 0.035. Then 0.0272. Then this is easy, 0.0078, 0.0022, this divided by 30, 0.001. So this is the density that we have found. Now moving on to the next part. Okay, moving on to the next part. What proportion of observations are between 25 and 40? Okay, so between 25, so basically somewhat from here till 45. Now we will split this 20 to 30 into two parts, 20 to 25 and 25 to 30. So this consists of 0.194 observations. So we'll have 0.194 by 2 observations coming here and by 2 coming here. So 0.194 divided by 2, 0.097. So this is the number of observations that lie between 25 to 30. And then 30 to 40 it is already given to us. So it is 0.078. Similarly, this is given for 20, for a class width of 20. Okay, so we will divide it by 4. So we'll split this into 4 parts, 45 to 50, 50 to 55, and then 55 to 60. So the proportion would be 0.11 in every part, 0.011, 0.011, 0.011, 0.011. So basically we are concerned with this, and this. So it would be 40 to 45, 0.011. So the total would be 0.097 plus 0.078 plus 0.011, 0.186. So this would mean close to 18.6% of the observations lie between 25 to 45. Okay, so we are done with this as well. Now moving on to the next question. Okay, now it is given the students A1, A2, A3 go to the college on any given day with probability of PAI where I equals to 1, 2, 3. Suppose that the event of A going to college is independent of A2 going to college on any given day. So we know first thing that they have told us probability of A1 intersection A2. because they are independent, this would be equal to probability of A1 into probability of A2. This they have mentioned. Now this is given to us that all of them are going to college, A1 intersection A2 intersection A3, and this is coming out to be 0.04. Okay, now the third thing they have given is probability A3 given A1 intersection A2. So this is nothing but probability A3 intersection A1 intersection A2 upon probability of A1 intersection A2. So this is given to us as 0.25. And the last thing that is given to us, probability of A2 equals to 4 times probability A1. Okay. Now with the help of this we already know, this is 0.04. So solving this, probability of A1 intersection A2 is 0.04 divided by 0.25. So 0.04 divided by 0.25, this is coming out to be 0.16. So we have solved this. And since 0.16 would be equals to probability A into probability B. So we have found this. So probability A1 is, suppose probability A1 into probability A2. Probability A2 is this. So this would be 4 times probability A1. So we have this implies 4 probability A1 square is 0.16. So probability A1 square is 0.16 upon 4, which is 0.04. So probability of A1 would be 0.2. We have found this. And if probability of A1 is 0.2, then probability of A2 would become 4 times of this, which is 0.8. So far we know these things from the given data only. Now if the probability of all the 3 students not coming to college on any given days is 0.06. So basically all of them are not coming means probability of A not coming, A1 not coming, A2 not coming, A3 not coming. This is equals to 0.06. What is the probability that at least one of them will come to college on that day? Okay, so basically 1 minus probability no one is coming. So it would be 1 minus probability A1 not coming, A2 not coming, intersection with A3 not coming. So 1 minus 0.06, which is 0.94. Okay. Now looking at the second part, evaluate probability A1 union A2. So probability A1 and interpret it equals to probability A1 plus probability A2 minus probability A1 intersection A2. So A1 we have already found 0.2, A2 is 0.8 minus A1 intersection A2 is 0.16. We already found this. So this is 1 minus 0.16, this is 0.84. So this means, so with probability 80, so the probability that either A1 or A2 or both of them will come to school is 84%. Or the probability is 0.84. Or the chances that either A1 or A2 or both of them will come to college is 0.84. This is how we will interpret it. Okay. Now the third part. If A2 has come to college on any given day, what is the probability that A1 and A3 will also come to the college on that day? So basically the condition is that A2 has already arrived, and then we are supposed to find, okay, I'll solve it here, that A1 and A3 will come given A2 has already come. So this would be A1 intersection A3 intersection A2 upon probability of A2. So we have already found these values. So it would be easy only So this is 0.04, this is 0.04, and the probability of A2 was 0.8. So this would come out to be 0.04 divided by 0.8, 0.05. Okay, so we are done with this. Now we'll move to the next part. Okay, this is one of my favorite question. I have already asked this in some of the internals as well. Okay, a bookstore purchases 3 copies of a book at rupees 6. So the cost for them is rupees 6. Cost per book is rupees 6 and sells each at rupees 12 each. So the price that they are charging is rupees 12 per unit. Unsold copies are returned for rupees 2. So the unsold copies are getting rupees 2. This is the PMF of X. So where X would denote the number of copies sold. So if X is 0, the probability is that 0 copies would be sold with probability 0.1. And now if 0 copies are sold, then we would have 3 copies unsold. Okay. Now look at this. This is the PMF given to us. Now what we are supposed to find, the PMF of the net revenue function. Now what would be the net revenue? Since they have asked about net revenue, not only revenue. So net revenue is total revenue minus total cost. So total revenue is 12 times, 12 times the number of copies sold, X. Suppose the copies sold are X, which is given to us. Okay, this is the total revenue. And we know, so at max there are 3 copies that can be sold. So 3 minus X would be the number of copies that are not sold. So that will fetch you a revenue of 2. And then minus total cost, which is 6 times X. Okay, so this shows the revenue from the copies which are not sold. So if you will solve this, this would become 12x plus 6 minus 2x minus 6x. So this is 12x plus 6. The total cost is this much. Okay, let me just check it once. Okay, it won't be 6x because this was the total revenue. This depends on X, but the seller has already purchased 3 copies. So it would depend how much he is able to sell. This distribution is telling how much he is able to sell on that day. A bookstore, how much he is able to sell. But he has already purchased 3 copies. So this is a fixed cost. Okay. So this would be 6 minus 2x minus 18. So we'll have 10x minus 12. So this would be the net revenue function. Suppose this is y. Okay. 10x minus 12. 10x minus 12, I'll just write it above. Y equals to 10x minus 12, which is a function which can be written as h of x as well. Now we were supposed to find the PMF of the net revenue function. So if x is 0, 1, 2, 3, y would be, if x is 0, so y would be 10 into 0 minus 12, which is minus 12. If x is 1, then y would be 10 into 1 minus 12, which is minus 2. If x is 2, y would be 20 minus 12, which is 8. And if x is 3, 30 minus 12, which is 18. So with the probability of x was 0.1, 0.2, 0.2, 0.5. So this, if you remove this, this is the PMF of the net revenue function. Corresponding to this, so with probability 0.1, you will end up earning a revenue of minus 12. with probability 0.2. So 0.1, with probability 0.1, you will be able to sell 0 copies and hence your revenue would be minus 12. Whereas with probability 0.2, you would be able to sell 1 copies and your revenue would be minus 2. Okay. And yours, okay. Okay, so this is done. Now, first part is done. Expected value and variance of x. Expected value is summation x into px. So this would be 0 into 0.1, which is 0, 1 into 0.2, 0.2, 2 into 0.2, 0.4, 3 into 0.5, 1.5. So 1.5 plus 0.6, which is 2.1. So your expected value, so it is expected that you would be able to sell 2.1 copies on an average. Now, variance x is expected x square minus x bar ka whole square. So expected x square would be 0 into, okay, I'll write it here. Expected x square would be 0 square into 0.1 plus 1 square into 0.2 plus 2 square into 0.2 plus 3 square into 0.5. So this would be 0, this is 0.2, then 4 into 0.2, 0.8, then 9 into 0.5, which is 4.5. So this is total coming out to be 5.5. So 5.5 minus 2.1 whole square. So the end value would be 5.5 minus 2.1 square, 1.09. So this would be the variance. Now you are supposed to find the C part, expected value and variance of the net revenue function. So the net revenue function was 10x minus 12. So the expected value of y would be 10 into expected x minus 12. So expected x was 2.1. So this would be 21 minus 12. So this would be 9. Similarly, variance of x would be, so variance of x is 1.09 and variance of y, which is 10x minus 12. So the variance would be 10 square, basically 100, into variance of x minus 12. So minus 12 would cancel out. It won't be there. So you should know this formula. This is the basic formula only. That variance of ax plus b equals to a square variance x. So this, using the same logic, it would be 100 times variance of x. So 100 times into 1.09, which is 109. Okay, so this is also done. Now find, okay, we need to draw that again. Now you are supposed to find probability the expected revenue is greater than equal to 8. So we had the probability of x, which corresponded to the probability of revenue of x as well, which was y, which was hx, right? So we know with 0.1 probability he was earning minus 12, with probability 0.2 he was earning minus 2, and with probability 0.2 he was earning 8, and with probability 0.5 he was earning 18. Now what we need to find the probability that y is greater than equal to 8. So this plus this, which is 0.2 plus 0.5, which is 0.7. Okay, so this was straightforward only. Now I'll take a minute break, just have some water, and then we'll go through the third and the fourth question. Okay, now starting with uh, starting with question 3. It is given 1% of all individuals in a certain population are carriers. So carriers are 0.01 of the total population are carriers of a particular disease. So this much of the individuals are infected. So not carriers are 0.99. A diagnostic test for the disease has 90% detection rate for carriers. For carriers, the detection rate is 0.9, not detection 0.1. Oh, okay, so it would be, so since they are mutually exclusive, and a 5% detection rate for non-carriers. So the test, so think from the perspective of COVID test, even if you are a carrier, it can show that you don't have COVID, even if you're suffering from COVID. So this is the probability. Point 1, that you are a carrier, but it is showing that you are not a carrier, you don't have the disease. And not carrier, so this is the proportion of population who are not carrier, and with 5% what they're saying is that the person has the disease, and with remaining 95%, so they are saying that so the virus is not being detected. Okay, suppose the test is applied independently to two different blood samples from the same randomly selected individual. Draw the tree diagram for the question. Okay, so we are supposed to draw the tree diagram. I'll draw it here. So starting with this, an individual can be a carrier or a non-carrier. The chances of carrier is 0.01. The chances of non-carrier is 0.99. And if he is a carrier and a diagnostic test is conducted on him, the chances that it would be detected, it is 0.9, and the chances that it won't be detected, not detected, it is 0.1. So this is already given to us. So detected. This is a scenario in which the person doesn't have the disease, but the test is showing that the person has got the disease. So this would be 0.05. This is given in the question itself, this thing. So the remaining would be not detected would be 0.95. Okay, so we are done with the first part. Now what they are asking is, what is the probability that both tests yield the same result? So we were applying the test independently to two individual blood samples. So let's define some events. Let B be the event that both tests yield same results. Okay, let C be the event that the tested person is a carrier. And let BP be the event that both tests yield a positive result. Both tests yield a positive result. Now we are supposed to find what is the probability that both tests yield the positive result. Both tests yield the same result. Okay, so it is the probability B that we are supposed to find. Okay, I'll write it here. So probability B that both tests yield the positive result given that the person is carrier into probability of carrier plus both tests yield the same results given that the person is not carrier into the probability that the person is not carrier. So probability of a carrier is 0.1. So since we are talking about two individuals, we are doing two tests, right? We are talking about two tests. Now probability of B given C. So it would be So it's the case that the person is a carrier. So either both the tests should show detected. So in that case would be 0.9 into 0.9, or the case when both the tests show 0.1, that both the tests show that they are given that they are carrier, it is not detected. That is, the test is giving the same result. So 0.1 into 0.1. This is, we have talked about the carrier. What about the non-carrier? Probability of C dash is 0.99, and then both the tests give the same result. It would be if both of them are detected, given that they are a non-carrier, so 0.05 square plus 0.95 square. Okay, so if you'll solve this, this would be 0.9 square plus 0.1 square into 0.1. This is coming out to be 0.082 plus this term 0.05 square plus 0.95 square into 0.99. This is coming out to be 0.89595. So you are supposed to write answer with 2 or 3 decimals. They have mentioned in the exam in the beginning as well. 595 plus 0.082. So this is coming out to be close to, okay, so this is not 0.1, this is 0.01. Okay, so this is, so one more 0 would be added here, 0.0082. So if you add this 0.89595 plus 0.0082, it is coming out to be 0.9041415. Okay, so we have done the second part. Now I'll just, okay, I'll just erase this. Now, and this. Now we are supposed to do the third part. If both tests are positive, so this is given that both tests are positive, what is the probability that the selected individual is a carrier? So we need to find probability C given both tests are positive. So first, probability of BP, that both tests are positive. So this is probability of BP given he is a carrier into probability of carrier plus probability BP given he is not a carrier into probability he is not a carrier. So this would be, so since we are talking about both the tests, probability of carrier is 0.01 and both tests are showing positive result. So this would be detected, 0.9 square into 0.9 square plus both are non-carrier, probability is this, and it is detected that, so both tests are positive. So in that case, it is a non-carrier, but it is detected. So 0.05 into 0.05 square. So solving this, 0.01 into 0.9 square plus 0.99 into 0.05 square. So the value that you will get is close to 0.01075. Okay, at least till 4 decimals. You can round it off. Okay. Now we were supposed to find probability C given both tests are positive. That the person is a carrier given the both tests are positive. So this is nothing but probability given C into probability C. So you must know these formulas by heart by now. Into divided by probability of, if you don't remember this, just go through your book once, because I don't have enough time to solve this right now. So this would be equals to, we have already found this, given C into C, this part, this was this thing. So 0.01 into 0.9 square upon probability of BP was 0.010575. So 0.01 into 0.81 divided by 0.010575. So this is coming out to 0.76595. So this is the probability that given both this is the probability that given both tests are positive, that the person is a carrier. Okay. Now moving on to the next part. Okay, this one is fairly easy and basic. Okay. Let x be a random variable with CDF. So this is the cumulative distribution function. Find the PDF of x. So we know f dash x would give you the PDF. So derivative of 0 would be 0 itself. So fx, which is equals to f dash x, right? So it would be 0 when x is less than 2. Okay, no need to draw this line. It would be 0 when x is less than 2. Then the derivative of this. So d by dx of x minus 2 by 2. This would be equals to half. Derivative of this would be half. So half when x lies between 2 and 4. And then derivative of 1 is 0. 0 when x is greater than equal to 4. So the PDF would be this. You can write it as fx is half when x lies between 2 and 4 and 0 otherwise. Okay, so this is done. Now we are supposed to find the probability of, okay, look at the second part. We have done this. Find probability that x lies between 2 by 3 and 3. So for x less than 2, it is 0 only. We can solve this with the help of cumulative distribution only. So the lower limit we can take it as, instead of 2 by 3, we can take it as 2. Because below this, so x is, for x less than 2, the fx is 0. So for x equals to 2 by 3, fx would be 0 only. Okay, so for this, we can solve this. Since x lies here, so it would be, fx would be 3 minus 2 upon 2, which is half. So the probability that x would lie between 2 by 3 and 3 is half. Probability x is greater than 3.5. So since this is a continuous distribution only, probability x greater than 3.5 equals to 1 minus probability x less than equal to 3.5. So 3.5 to 2, since it is defined on this interval only, so it would be 1 minus 3.5 minus 2 upon 2. So this is 1 minus 1.5 by 2. So this is 1 minus 0.75. So this is 0.25. So the probability is 0.25 that x is greater than 3.5. Okay. Now moving to the next part. Find the 60th percentile. Now you need to find, suppose f of z equals to 0.6. So at value of z, we are having the 60th percentile. That would mean it would be satisfied for this only. Z minus 2 upon 2 is 0.6. So Z minus 2 equals to 1.2. So Z equals to 3.2. So when we have x equals to 3.2, that would be the 60th percentile, which would mean 60th percentile, which means below 3.2, 60% of the observations would lie. Okay. Now find probability x equals to 3. Since it is a continuous distribution, the probability of any number is 0. Okay, so this was fairly basic. Now we'll move to the fourth question. Okay, suppose that Delhi witnesses only two types of days, rainy or sunny. The probability that a rainy day is followed by a rainy day is 0.8. So basically, I'm just looking for some space. Okay, I'll do it here. So what they are saying is, suppose this is about today's weather. If it is rainy or it can be sunny. The tomorrow's weather can be rainy or can be sunny. Now what they are saying is, the probability that a rainy day is followed by a rainy day is 0.8. So if today is rainy day and the next tomorrow is also rainy day, so the probability is 0.8. Right? So if today is a rainy day, the chances of a rainy day tomorrow is 0.8. So the chances of a sunny day would be 0.2, because any of these two conditions would occur irrespective of what day it is. And the probability that a sunny day is followed by a the probability that a rainy day is followed by a rainy day is 0.8, and probability that a sunny day is followed by a rainy day. So if you have rain today, so this is rain today and rain tomorrow. So what they're saying is, the probability that if today is a sunny day and the next day is a rainy day, that probability is 0.6. So given today it is a sunny day and the next tomorrow is a rainy day, that probability is 0.6. Okay, if you want, I'll repeat it again. So what they're trying to say is, first part would be clear only. Now look at this. The probability that a sunny day is followed by a rainy day. So sunny and then rainy. This probability is 0.6. So sunny already for today and then rainy for tomorrow. So the remaining probability would be 0.4. Now this is an interesting question. I enjoyed solving this question. So find the probability that a rainy day is followed by. Okay, now we are supposed to find the probability that the rainy day is followed by a rainy day, a sunny day, and another rainy day. So the sequence is, initially it is a rainy day. This is given to you. Then rainy, sunny, and then rainy again. So it would be probability second day is rainy, given first day is rainy. First day is rainy. So this is this thing. Then the next day is sunny, which means probability third day is sunny, given second is rainy, into then another rainy. That probability fourth day is rainy, given third is sunny. This is the probability that we are supposed to find. Now the question is very easy if you are able to infer this much. Now look at this. Probability second day is rainy, given first day is rainy. So today this is rainy, and given the chance of the next day rainy is 0.8. So this is 0.8. Right? Now the third day is sunny, given the previous day was rainy. So this day would become today this time. And now rainy, it is already rainy today, and what is the probability that it would be sunny the next day, given it is rainy on the second day. So this is 0.2. So into 0.2. Similarly, for this, third day is sunny. So third day is sunny. This is third, and then this would be, tomorrow would be fourth. The fourth is rainy. So third is sunny. We have here this portion, and fourth is rainy. So we have at this. So this would be 0.8 into 0.2 into 0.6. This is coming out to be 0.096. Okay, this is done. Now the probability that a rainy day is followed by sunny, sunny, and then rainy. So now we need to find probability second day sunny given first rainy into probability third day sunny given second is sunny into probability fourth is rainy given third is sunny. So given rainy, the probability of a sunny day, given rainy, today rainy, then the probability that the next day would be sunny is 0.2. So this is 0.2. And the probability the third day is sunny given second day is sunny. So sunny and then sunny again, this is 0.4 into 0.4. Then fourth day is rainy given third is sunny. So given sunny, the next day is rainy is 0.6. So 0.6 into 0.2 into 0.4. This is coming out to be 0.048. Okay, so we are done with the second part as well. Now the third part states no sunny days for 3 consecutive days. So it is rainy first day followed by rainy, rainy, and rainy again. So this would be probability. Second is rainy given first is R. Then probability third is rainy given second is R. Then probability fourth is rainy given third is rainy. Okay, so the first day rainy and the second day would be rainy, the probability is 0.8. Same probability would be same in all the cases. So 0.8 cube. So 0.8 power 3 or 3 times, which is coming out to be 0.512. Okay, now the last part, fourth part, rain 2 days later. So rain followed by sunny, sunny, and then rainy. So probability sunny, second day is sunny given first is rainy into probability third is sunny given second is sunny. Then probability fourth is rainy given third is sunny. So this would be probability given rainy, it is sunny. So given rainy, it is sunny, which is 0.2. So this is 0.2 into sunny given sunny. So this is 0.4. And the third is rainy given sunny. So given sunny, it is rainy 0.6. So into 0.6. So this is 0.2 into 0.4 into 0.6, 0.048. Okay. So this must be clear. Okay, so we are done with fourth A. We're left with B. B consists of 2 parts, so I'll just take a minute's break. Okay, now moving to the B part. The time t in days required for completion of a contracted project is a random variable with PDF. This 0 otherwise for t greater than 0. Suppose the contracted project must be completed in 15 days. So they are trying to complete the project in 15 days. If t is less than 15, there is a cost of rupees 5 into 15 minus t. And if t is greater than 15, there is a cost of rupees 10 into t minus 15. Find the expected value of the cost. So the cost function becomes, with the function of time, 5 into 15 minus t when t is less than 15, and it becomes 10 into t minus 15 when t is greater than 15. So this is given to us. Now we need to find the expected value of the cost. Okay, so the expected value of cost would be the range of the function is, so this is defined for t greater than 0, 0 till infinity, ht into dt. So this is ht into dt. Now the function would be, because it takes different values, the intervals would be 0 to 15. 0 to 15, the function was 5 into 15 minus t. So 0 to 15, 5 into 15 minus t, ht into ftt. Okay, we need to incorporate this as well. So I'll just do this again. ht into f of t into dt, because this is the expected time and then the cost associated with it. Okay, so we have, this would be from 0 to 15 first, 5 into this thing, 5 into 15 minus t, 5 into 15 minus t into this function 0.1 e to the power minus 0.1 t into dt plus 15 to infinity, the function would be 10 into t minus 15, 10 into t minus 15 into this as it is function 0.1 e to the power minus 0.1 t into dt. So this is your actual expected cost. Now I'll just tell you how to differentiate this. You need to put the limits by your own. Now on differentiating 0.1 e to the power minus 0.1 t into dt, I'm not writing the limits. You can just write the limits, and I hope you know the, after solving for the integral, you need to put this limit. Suppose this is b, this is a, so you need to put, so if you solve this, suppose you get something like this, then you need to put the value of b in the whole function in place of t, and then subtract while putting the value of a in the whole function. Okay, I hope this much integration you know. Okay, now integral of this would be, the integral of this is 0.1 e to the power minus 0.1 t upon minus 0.1. So minus this cancels out, so this is minus e to the power minus 0.1 t. So this is the integral of e to the power minus 0.1 t. Okay, now so you can expand this up. So this would become 75 minus t into 0.1 e to the power minus 0.1t. So this would become 75 into 0.1 e to the power minus 0.1t minus t times 0.1 into e to the power minus 0.1t. So I have integrated, I've told you the integration of this. You just need to do basic expansion here as well. And so you need to put the limits on this. For the other function where we have something of the form t into 0.1 e to the power minus 0.1 t dt. So we will do integration by parts. I'm not sure whether you remember this or not, but I'll do it here since this is a part of the question only. On doing integration by parts, we'll take t as our first function and this whole thing as our not dt second function. So by integration by parts, we have first function into integral of second minus whole integral of derivative of first into integral of second. So for this, we have already solved the integral for this. This was coming out to be this thing. So first function into integral of this. First function is t into integral of this. This is minus of e to the power minus 0.1t minus whole integral of derivative of first function, derivative of t is 1 and integral of second still same thing. So minus this would become plus 0.1 t dt. So this would be minus t e to the power minus 0.1 t and the integral of this would be plus e to the power minus 0.1 t upon minus 0.1, and then you can put the limits to find what the exact value you are getting. Okay, I'm not putting the limits because it will take a lot of time. You need to try this on your own. Okay, now I'll do the last part of the last question of fourth part. Last part of fourth question. Okay. Consider the experiment where product items are being inspected for the presence of a particular defect until the first defective product item is found. So this is a geometric series, geometric probability distribution. Let x denote the total number of items inspected. Suppose a product item is defected with probability p is greater than 0. Independently of other product items, find expected x in terms of p when PMF is given by this. So basically they have asked you to find the mean of a geometric. So basically they have asked you to prove the mean of the geometric probability distribution. So Px is 1 minus p x minus 1 into p, right? For x would be 1, 2 till keeps on going. Now expected x would be summation x equals to 1 to infinity x into px. So the px, the whole function. So it would be 1 minus p x minus 1 into p. This would be the expected x. Now this can be written as p times expected x equals to 1 to infinity x into 1 minus p x minus 1. Now put the value of x equals to 1. You will have this p times, this would become, when x equals to 1, it would become 1 into 1 minus p to the power 1 minus 1, which is 0. So this would be 1. When x is 2, this would become 2 times 1 minus p to the power 1. So 2 1 minus p plus 3 times 1 minus p square. and this will keep on going. So let we would have this thing, we can write it as S, this whole thing as S, where S is equals to 1 plus 2 into 1 minus p plus 3 into 1 minus p square plus so on. Now suppose we write 1 minus p into S. This would be 1 minus p, then plus 2 into 1 minus p square plus 3 into 1 minus p cube and so on. So if you'll solve this S minus S, so if we'll subtract this, we'll get S minus 1 minus p into S, which would be S minus S plus PS. So PS would become equal to 1, this term, then if you'll subtract this, you will get 1 minus p, then if you'll subtract this, you'll get 1 minus p square, and then it will keep on going. So PS would become, so the common factor is 1 minus p, and you must know one summation of this would be 1 by 1 minus r, where r in this case is 1 minus p, and r when mod r is less than 1. So p is greater than 1, so 1 minus p is less than 1. So this would become, okay, so PS would become 1 upon 1 minus r, which is 1 minus p. So this would be 1 upon 1 minus 1 plus p. So 1 cancels out. So PS becomes 1 upon p. S becomes 1 upon p square. Okay, now we have found this. Now the expected mean was p into S, because this whole term was S. This whole term was S. So p into S is the expected mean. So the expected mean would be, expected of x would be p into S, which is p into 1 by p square. So this is 1 by p. So the mean is 1 by p, and we have proven this. And in the next videos I'll make only one more video for the same, in which I'll cover the whole part B, where we are left with only 3 questions. So I'll try to solve this as soon as possible. Okay, so I'll solve this. We're left with this only. Okay, so all the best for your exams.